Good day, everyone. I just want to welcome you to Grade 12 Physical Sciences. Today we'll be doing the revision of physics. This is a revision of grade 11 work. I want to welcome you once again. Physics is the easiest subject to pass in grade 12. If you're doing physics, just know you are more eligible to pass than fail. So today I want us to look at the types of forces. What exactly is a force? We say that, as you can see here, a force is a push or a pull exerted on an object in order to cause it to move or to slow down. We can apply a force on an object in order to make it move or make it stop. What are the types of forces? We have two types of forces. We have the contact forces and we have the non-contact forces. And the first contact force, or let's explain what contact forces are. Contact forces are forces that act on an object directly in contact with it. So if a force acts on an object, that force must be directly in contact with that object. Let's say this pen here is an object. For me to move this pen here, I have to touch it and move it around like this. We call this a contact force. A non-contact force, like gravity. If I hold this pen like this here and I let it fall, what is the only force acting on this pen to make it fall? Of course, is the force of gravity. The force of gravity is not in contact with this pen, but this pen here still falls. So we call that a non-contact force. Let's look at the types of contact forces. The first contact force is force applied. You can see here I put symbols. You will use these symbols in your free body diagram. The symbol for force applied is either you write FA or just F, like that there. Sometimes it is called FE, the force of engine in motors and vehicles. We say that those vehicles and motors move under the force of engine. So what is a force applied? Well, it's a force applied externally, like it is self-explanatory. We apply a force externally on an object in order to cause it to move or slow down. That is an applied force. We have another type of force. We have the normal force there. The symbol is N or F of N. You will use it in a free body diagram. What is a normal force? We say that a normal force is the force exerted by a surface on an object in contact with it and acts perpendicular to the surface. That is a normal force. We have another type of contact force, which is the frictional force. We say that the frictional force is the force that opposes the motion of an object and acts parallel to the surface, like that there. The symbol for frictional force, you can say F or F of F. The frictional force is divided into two. We have the static frictional force. What is a static frictional force, or Fs max? The Fs max stands for maximum static frictional force. But what is that static frictional force? The static frictional force is the force that opposes the tendency of the motion of a stationary object. Like, I'll give you an example with this pen. This pen here has the tendency to move. What is stopping this pen from moving? Of course, it is the static frictional force. But if I start pushing it like this, it will start moving because my applied force is greater than the maximum static frictional force. But if the force I apply like this here is less than the static frictional force, then the pen here will not move. I'm recording this while it is raining outside. Don't mind the noise there. It's just the rain. I'm recording this while it's raining. Another type of frictional force is the kinetic frictional force, which opposes the motion of a moving object relative to a surface. You can use Fk for kinetic frictional force. It always opposes the tendency, it opposes the motion of a moving object relative to a surface. If this pen is moving to the east, just know that kinetic friction is moving to the west. If this pen is moving to the west, just know that kinetic friction is moving to the east. It always opposes the motion of an object. We have another type of contact force, which is the tension force. The tension force is a force exerted by a cable, a string, a rope, etc. etc. We call that the tension force. And we have another type of contact force which we will not do in grade 12, but when you continue doing like engineering, physics, let me say physics in details, when you do physics in details, you will deal about that contact force. It is called air resistance. The air resistance, it slows down your speed when you are moving. Like when you are in a car, you hear the wind blowing your windscreen, that wind there, it slows down the speed of your car, so that your car will not speed more than it should. And yeah, when a car is moving, it overcomes many obstacles in order to slow down its speed. It has to overcome friction, and it has to overcome the air resistance. Now, I want us to talk about the non-contact forces. I told you that the non-contact forces, they do not have to be directly in contact with the object in order to act on that object. The first, if you look on the right side of your screen, you can see there we have examples. The first example of a non-contact force is a gravitational force. A gravitational force is a force exerted by a planet on an object on or near its surface. That object needs to have mass. If you are near the surface of the earth, then the earth will exert a force of attraction on you. I gave this example a few months ago. If you are in space, you are able to pose any gesture, you're able to post. You are busy, you are slowly moving towards the earth. But once you enter the spheres of the earth, either the troposphere, the hemisphere, whatever you call it, you have no time to pause, because you'll be falling at a very much greater acceleration. So there is no time to pause, unlike in the space. Like I told you, in the space you are busy being attracted towards the earth, towards the center of the earth. Once you enter the spheres of this earth, you are no longer able to pause, because you'll be falling at a very greater acceleration. Now, what is another type of non-contact force? We have the electrostatic force. It's a force between charges. The charges can either repel or attract each other. We will talk about electrostatics when we continue our lessons forward. Another type of non-contact force, we have the magnetic force. This is a force between magnets. We know that magnets of the same poles repel each other, and magnets of the unlike poles, they will attract each other. That's it about this video here. I just wanted to look into deeper details about the type of forces that you will encounter in physics grade 12. you will only be doing 5 forces when coming to neutron's laws, which we will talk about in another video. We will talk about these 5 forces are called force applied. It is the first force that we'll be doing in grade 12. Another force is the normal force. After normal force, we have the frictional force. After frictional force, we have the tension force. After tension force, and lastly, we have the gravitational force. These are the 5 forces that we'll be doing, and you must know the definition of each force there. And yeah, these forces here can act at different angles on an object. Like here, I wanted to show you this. Applied force can act parallel to the surface. It can act at an angle like this here. We will talk about this in the next videos, and I hope you can see it there. Let me put it here. Also, the tension force can act like the applied force, but applied force and tension are different forces, but they can act at an angle or horizontally or parallel to the surface. And we have this here, the normal force, which always acts perpendicular to the surface. If the surface is flat, then the normal force acts at 90 degrees to that surface. If the surface is inclined like this, then normal force acts 90 degrees to that surface here. Not this object. It does not act 90 degrees at this object. It acts 90 degrees at this surface here that the object is on. And if the surface is also inclined, then the normal force will act 90 degrees to that surface here, not this object, but the surface, as the definition says. Like I told you, you must memorize the definitions of these forces there. They might ask 1 or 2 of them. Here we have a friction. If the object is, I hope you can see that, if the object is moving to the right, then frictional force will cause this object to slow down, like it will act against this object here. If this object is moving to the right, then friction will move to the left. If the object is moving to the left, then the friction will move to the right. If the object is moving up the incline, then the frictional force will act down the incline. If the object is moving here is up the incline, then the frictional force will act down the incline. If this is down the incline, then the frictional force will move up the incline. Like it's always opposite to the direction of motion. If you are moving east, then frictional force is moving west. If you are moving north, then frictional force is moving south, like that there. And we have the last force that we'll be looking is the gravitational force. Now it doesn't matter whether it's inclined or horizontal, but the gravitational force always acts vertically downwards, like this. Always it acts vertically downwards. It does not change. It only changes on the incline, where we have FG parallel and FG perpendicular, which I think you are familiar with, and we will do them in the next video. This is what I wanted to highlight there, because there are still some people who can't draw free body diagrams, and that hurts a lot, to lose such free marks. You will see a student getting like 1 out of 5 marks instead of getting all those 5 marks for a free body diagram. We will do free body diagrams in the next video. I just want to conclude this video here, and after doing free body diagrams, we will do the incline and the horizontal surface. After that, we will do the Newton's laws one by one. I thank you for watching this video. Do recommend it to your friends who will need the tips in these videos. Recommend this channel to them and tell them to subscribe, and tell others who are doing physics to do the same. Thank you. I'll see you in the next video.